In this series of videos I'm trying to give some advice on how to repair certain items, and mostly this relates to vintage equipment. I repair and restore a lot of vintage equipment, and there's very frequently a need to carry out some fairly difficult repairs, and so really what I'm trying to do is get across some of the experiences I've had trying to effect these repairs. Hopefully some of this will help anyone watching the video that has a similar piece of equipment to repair, or it might just be that you find this information interesting. I'm not trying to suggest that this is the only way to carry out these repairs or the best way, but this is the way I carry them out with the equipment and the skill set that I have. How you go about it is entirely up to you, but as I say, hopefully some people might find these videos of interest. So in this video I want to look at the way I go about repairing something like this. You may recognize this from a fairly recent video, and this is from a vintage reperforator, and I will be posting a series of videos on the repair and restoration of that in the future. One of the first tasks is to repair this, and when I posted the first video I did get several comments about the way some people might want to go about repairing this, and so I thought this would be a good opportunity to explain the way I go about doing this. What I'm aiming for is something that will look authentic, so it will look almost exactly the same when I'm finished, but I want it to be at least as strong as it was before it was broken. And that's one of the key things. Is a lot of time I get equipment that has failed repairs, and there's sort of araldite or various weird and wonderful repair attempts, and that actually makes life a lot more difficult. If you get a repair like this and it's got araldite everywhere, or any other kind of adhesive, or someone's tried to braze it, then all manner of things like that cause a lot of headaches when I try and carry out a final repair. This is cast aluminium, and it's very old cast aluminium. Basically it's pot metal. This weighs almost nothing. It's mostly air, and so trying to repair it's very difficult. The other thing to bear in mind is this is a very thin wall section piece of metal. So what you could do, of course, is modify it. You could put another block in here, you could machine a block and screw it in, and whatever else, but this is visible from the outside of the machine. This is a visible part, a very visible part of this machine. So because this is quite a rare piece of equipment, I want to try and repair this in a way that has the least visual impact on the final result. Some of the people suggested drilling and pinning this and then using araldite. I wouldn't attempt that with something like this on such a thin wall with this type of metal. This is extremely brittle and very weak, and if you try to drill it and pin it, this is about 2.5 millimeters across. Almost certainly what would happen as soon as you try and bend it, it would just break out the side of the holes that you drilled and then fall apart, and you'd have a bigger problem to deal with. Just using araldite almost certainly will not work here. There's not enough surface area, and there is a lot of force on this when it's in use. This is part of the working frame of the machine, so a lot of problems in trying to repair this. So the method I would use for this is actually to weld it. I'm talking about a proper weld, not aluminium brazing, and the type of welding I prefer for most repairs, but especially for something like this, in fact the only type of welding I would even consider for this, is TIG welding. And if you're not familiar with TIG welding, it is a very difficult form of welding to master, but once you have a reasonable handle on it, then it's extremely versatile. But it's one of those methods that you have an immense amount of control over once you figure out how to do it. That said, because you have a lot of control over the process, it gives you a very wide scope for messing it up. So it is definitely a skill, but it's one that I think is well worth acquiring if you do a lot of repairs like this. So the first thing I would do in trying to repair this is I would strip all the paint off, it will have to be repainted anyway. And so I would bead blast this and get it back to bare metal. There's a lot of oil in this, so I probably wouldn't bother trying to clean it. A lot of people, professional welders, say you must clean it, soak it in acetone or something. I generally don't do that. You can do it, it'd probably make life easier. But what I tend to do is, whenever I see an opportunity, bits of old equipment laying around that are going to be disposed of, even if I don't want it, I will take them apart. I won't switch them on, and take some of the parts out that I want. Now in this case it's not because I want the parts, I want the material. So something like this is out of an old piece of equipment about the same age as this, and it's an almost identical material. So this again is cast aluminium. It is also extremely dirty, as you can see, and what I do is I look for, I've got a huge stash of lumps of material like this, so I look for a material that very closely matches what I'm trying to repair. And what I can then do is use that material to set up the welder and the process. The thing with TIG welding, it's as much about the way that you weld as much as the materials that you're welding. So what I do is I find the best way to TIG weld the material, and once I've got that sorted out and can run a sensible weld on something like this, then I will move on and attempt the weld on the final piece of equipment I'm trying to repair. So in this case what I did, and this is the first step in trying to repair this, I found a piece of material that very closely matches this. It's almost identical and has a lot of the same qualities. You can't say for certain it's the same composition of this, it almost certainly isn't, but it's something that's very close in the way it seems to be behaving. And again, this is something you pick up as you do a lot of these. It becomes almost second nature as to what the issues will be with a given piece of material. What I then do is, as I say, develop the process with the TIG welder as to how I'm going to go about trying to weld this. Now if you're familiar with welding, it may look like an impossible task trying to weld a thin wall piece of cast aluminium that's mostly air and 50% dirt, but you can do it, it's just difficult. So in this case, while normally welding aluminium, I wouldn't bother grinding the tungsten to a point. I normally let it just ball up and use it that way. For this, because I want to have a very tight control over the arc, I grind it to a blunt point, and for this I would use a 1.6mm tungsten, but I will use a 2.4mm filler wire. I tend to do that because this will basically evaporate and vaporize as quickly as you look at it. Having the ability to put a lot of filler in quickly if you need to gives you a bit more control. I would also say I only ever use the TIG welder with a foot pedal. I'm sure there are welders out there that are good enough to do this without a foot pedal, but I would not attempt to weld something like this without a foot pedal. It's a very dynamic process and you're constantly adjusting the current. I couldn't actually tell you what the current is that I would actually use to weld this. Unfortunately I can never see the welder current display when I'm welding. But for this I had the welder set to 100 amps, so that's with the pedal all the way down. But I guess I was running somewhere between 35 and 65 to 70 amps for most of this, and it varies as you're running the process. I've got the cleaning set, AC of course, it's aluminium, so I'm using AC welding. I've got the cleaning set to about 28% for this, which might sound a bit low, but the reason I have it set so low is I know I can't weld this in a single pass. There's no point me trying to weld and clean and put filler in all in one pass. That just will not work on something like this. So what I've done with this is I've intentionally done a single pass, multiple passes to show you how I go about cleaning up the material. So we start off, the top one here, I don't know how well you can see this, but the top one is a single pass using the the welder, so you'd have the tungsten, get the arc started, move it across, and it starts to heat up and it starts to boil out or burn out the impurities. And then this one is probably 2 or 3 passes. I've got very low current set, so maybe 30 amps, and I'm just going back and forth trying to clear this up, and you'll see that at some point it will start to form a weld puddle. Most of the time when you're just cleaning it, it just looks like a mess and it looks like it's just going to be an impossible weld. But if you keep going and you manage not to overheat it, so the other thing is I'm not trying to melt all this away, I'm trying to control the amount of energy I'm putting in this so it doesn't just dissolve. As I say, this will dissolve and disappear almost instantly if you push the pedal down too far. And ultimately what you end up with is the ability to run a sensible bead and put filler in. So initially you're not putting filler in, you're just trying to clean up the material, doing multiple passes, very low current, and then you'll get to a point where a weld puddle will start to form. You can start to put filler in, and as long as you've got the metal clean all the way along, so you're moving your tungsten back and forth and you're looking for a continuous clean area, then you can insert some filler, as I've done here. And I don't know how well this comes across, but it's well and truly bonded to the base metals, so we have a proper penetration into the base metal. But again, I haven't destroyed the underlying base metal, it's still there. We've kind of obviously melted the top section of it, but it's a thin section, it's about 1.5 millimeters thick, but we've managed to get a good bead along the top. And I'll do this maybe 10 times on bits of scrap metal. So that was the first attempt. Again, same type of material. In fact, I think this is the end. I snap it in half just so I've got more than one piece to play with. And same thing, hopefully you can see, very nice penetration. I didn't bother cleaning this with anything. This is just using the welding arc to burn out all the impurities, and then when I get a decent clean puddle forming all the way along, it's not a full puddle because that would cause the material to start to sag, what I can do is start putting filler in, and you can see it hasn't destroyed the shape of the piece of material. So if this was on here, then what I would do is I would actually clean this. It's obviously more important. I won't go mad cleaning it, just get rid of the worst of the dirt and grease. The paint's already gone, I've bead blasted it of course, or at least I would have done, and the paint is still here at the moment, but I would bead blast it to start with. Then I would clamp this down to a metal plate, and that's for several reasons. I also would bolt this to the chassis so it's actually held in the correct location, and that's going to bring these two parts into roughly the right orientation. And that's important, is to get the thing solidly clamped down, because it will try to move with the heat of welding, and you don't want to weld it, get a perfect finish and find out it's like that. So I'll clamp it down for several reasons. One is to hold it in place, but the other one is to put a thermal mass on the underside. This is the outside that will be visible. I haven't ground anything yet, this is just as it is. What I will then do once it's all clamped in place is I will use a burr to grind out a recess along the break. I'll then use this process to try and clean up and get some filler and bring the joint back out. So I'm trying to get 100% penetration through the entire crack, but not just from one side. I'll try and go just over halfway from one side. I'll do the same thing on the back. So once I've done one side, I'll turn it round, grind away on this side, do the same process, fill it, bring it back out. I'll put too much in, so I end up with something that is proud of the surface. I'll leave that there until I've finished. I'll then flip it over and I'll do exactly the same thing from the outside. So I'll grind this until I'm well and truly into the weld that's come through from the other side, and then I'll backfill this with filler. Not weld filler, that is, not filling compound. So I'll weld it with filler rod and bring it back out again using the same process, and end up with something that probably look a bit like that. So it'll look horrible when you first do it, and then once you're sure that all the voids have gone, you grind it back, sand it very smooth to get the profile right, do the same on the inside to get it exactly the right shape. But what I've done is replace the area where the crack is with good new aluminium, higher grade aluminium than was originally used as well, so it should be nice and strong. And as long as I get good penetration into the surrounding metal as I've done here and manage not to cause any cracks, that's the other thing, is aluminium's got a habit of cracking if you don't control the heat properly, so it's making sure I'm not forming a crack where the end of the weld is, otherwise it's going to break but a bit further along. And once you get this done, you can grind it back and it will look like a new piece of metal. You can then paint it and it will be a completely invisible repair. It will just probably be stronger than it was when it was new. So that's how I go about this. It sounds like a complex process, and it is, but if you want to get into this, then it's a lot of fun apart from anything else. I wouldn't advise starting, if you're just getting into TIG welding, I would not advise starting on something like this. Just use flat rolled aluminium sheet, practice on that. But it is a lot of fun, and it's definitely a skill worth picking up if you do a lot of repairs. It will pay you back many times over, and the repair will be a proper permanent repair. So I hope you found it interesting. Like I said, it's TIG welding is a skill, and it's something that I think is well and truly worth developing as a skill and as a tool that you can use for working on equipment like this, and it will enable you to make extremely nice, reliable, robust repairs.